Next heading is shape of orbit traced. Shape of orbit. Next heading is shape. Shape of orbit. Shape of orbit. Shape of orbit traced under central. Shape of orbit traced. Traced under central. Under central. Attractive and repulsive inverse square force. Repulsive inverse square force. Yes, square force. Shape of orbit traced under central attractive and repulsive inverse square force. First point, first heading. Central attractive inverse square force. Central attractive inverse square force. Inverse square force. The polar equation of the orbit traced by a particle moving under a central force attractive inverse square force is given by 1 upon r equal to mc upon j square plus a cos theta minus theta naught. We have studied this behind it. Where m is the reduced mass of the particle, where m is the reduced mass of the particle, and see the force constant. See the force constant. And z the angular momentum. A and theta naught constant of motion. Constant of motion. To find the value of A, we shall find the turning point of the trajectory of the particle. Maximum and minimum value of R. Maximum and minimum value of R. Maximum and minimum value of R. In the above equation, theta minus theta naught equal to 0, cos theta minus theta naught equal to 1. Then 1 upon R has the maximum value. 1 upon R has the maximum value. And so 1 upon R max equal to MC maximum MC upon J square plus A. If theta minus theta naught equal to 180 degree, that means pi, and cos theta minus theta naught equal to minus 1, then 1 upon R has the minimum value. 1 upon R has the minimum value. 1 upon R has the minimum value. This is the equation number 1, minimum value, and show 1 upon R minimum 1 upon r minimum equal to mc upon j square minus a. This is the equation number 2. This is the equation number 2. Turning point. Which point? Turning point. Turning point. Turning point. The total energy E of the particle under a central force is given by E equal to 1 upon 2 m derivative of r square plus j square upon 2 m r square plus u where 1 upon 2 m derivative of r square equal to kinetic energy and 1 upon 2 m r square derivative of theta square. Derivative of theta square is the energy due to centripetal force. Is the energy due to centripetal energy due to centripetal force and u is potential energy. U is potential energy. U is potential energy. Then this is the where here U is the potential energy for a gravitational force of attraction obeying inverse square law. For a gravitational force of attraction. There are gravitational force of attraction obeying inverse square law. Obeying inverse square law. Where U equal to minus C upon R, where C equal to G M1, M2 and E equal to 1 upon 2 M derivative of R square plus J upon 2 M R square minus C upon R. For an electrostatic force of repulsion between two like charges in SI unit, U square equal to C upon R plus C upon R, where C equal to 1 upon 4 pi epsilon naught Q1 Q2. Then E equal to 1 upon 2 m derivative of R square plus J square upon 2 m R square plus C upon R. This is the equation number 3rd. Now because E the total energy is a constant, we can evaluate it at any convenient point on the orbit. We take the turning point where R is a maximum or minimum. At this point dr upon dt equal to derivative of R equal to 0. Thus the turning point is defined as a point at which the radial velocity derivative of R of the particle is 0. Of the particle is 0. In such a case, the kinetic energy of the particle is given by 1 by 2 m derivative of r square is 0, and total energy total energy total and total energy and total total energy and total energy E equal to J square upon 2 m r square minus C upon r is effective potential energy. Is effective potential energy. Potential energy. Effective potential energy. Because J square upon 2 m r square equal to 1 upon 2 m r square derivative of theta square is the energy due to centripetal force. Is the energy due to centripetal force and C upon R the energy due to gravitational attractive force. Energy due to gravitational attractive force. Gravitational attractive force. Thus, a turning point may also be defined as that point at which turning point are defined as that point at which the total energy is the total energy E of the particle is total energy E of the particle is equal to its effective potential energy. Effective potential energy. Turning point, that point at which the total energy E of the particle is equal to its effective potential energy. Value of F for attractive inverse force square. Next is value of A for attractive inverse square force. Attractive inverse square force. Considering the case of an attractive inverse square force at the turning point, E equal to J square upon 1 minute. E equal to J square upon 2 m r square minus C by r. Or J square upon 2 m 1 upon r square minus C 1 by R minus E equal to 0. This is the equation number 4. This is the equation number 4. This is an equation in 1 by R and its two roots give the value of 1 by R max and 1 by R minimum. The two roots 1 by R equal to C plus minus under root of C square plus 4 J square upon 2M into E upon J square upon M, where 1 upon R max. This is equal to 1 upon R. 1 upon R max, or 1 upon R max equal to MC upon J square plus in bracket MC upon J square in bracket whole square plus 2ME upon J square bracket is closed whole to the power 1 upon 2. This is the equation number 5. And 1 upon R minimum. 1 upon R minimum equal to MC upon J square minus in bracket MC upon J square whole square plus 2ME upon J square bracket close whole to the power 1 upon 2. This is the equation number 6. This is the equation number 6. Comparing the value of 1 upon R max, comparing the value of 1 upon R max with this in equation, so that in a equation first we have MC upon J square plus A equal to MC upon J square in bracket MC upon J square whole square plus 2ME upon J square bracket close whole to the power 1 by 2. Then A square equal to MC upon J square. MC upon J square whole square plus 2ME upon J square. 2ME upon J square equal to M square C square upon J to the power 4 plus 2ME upon J square. This is the equation number 7. 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 And if we orient our coordinate system such that theta naught in equal to in equation 1 upon R equal to MC upon J square plus A cos theta minus theta naught is 0, then 1 upon R equal to MC upon J square in bracket 1 plus AJ square upon MC cos theta. Bracket is closed. Comparing equation number 8. Comparing equation number 7. Comparing equation number 8. This is the equation number 8. Equation number 8. Comparing equation number 8. Comparing equation number 8 with the general equation with the general equation of conic in polar coordinates conic in polar coordinate. Comparing equation number 8 with the general equation of conic in polar coordinate. Then 1 upon r equal to 1 upon L in bracket 1 plus epsilon cos theta, 1 plus epsilon cos theta, where L equal to a constant, where L equal to a constant, where L equal to a constant, we find that it represents a conic section with L equal to J square upon MC and epsilon equal to AJ square upon MC. Epsilon equal to AJ square upon MC. The quantity epsilon is called the eccentricity and its value is given by 1 minute. The quantity epsilon is called eccentricity and its value is given by epsilon square equal to a square j power 4 upon m square c square equal to 1 plus 2 j square total energy E upon mc square, but epsilon equal to in bracket 1 plus 2j square E, 1 plus 2j square E upon mc square, bracket is closed, whole to the power 1 by 2. This is the equation number 9. This is the equation number 9. And the trajectory of the particle is given by, and the trajectory of the particle is given by trajectory of the particle is given by 1 upon r equal to mc upon j square in bracket 1 plus epsilon cos theta, 1 plus epsilon cos theta. This is the equation number 10. The shape of the trajectory of the particle depends upon the value of epsilon, hence on the relationship between the total energy E and its angular momentum J. First point, angular momentum J, first point. If total energy is greater than 0, then this is a positive. This is positive. Epsilon is greater than 1. The path is a hyperbola. The path is hyperbola. Second point. If total energy is 0 and epsilon is 1, the path is a parabola. The path is parabola. The path is parabola. And the third point, if total energy is less than 0, that means negative. So epsilon is less than 1, the path is an ellipse. The path is an ellipse. Ellipse. The path is an ellipse. The path is an ellipse. And fourth point. If total energy E equal to minus mc square upon 2j square, which that epsilon equal to 0, the path is a circle. The path is a circle. The path is a circle, as shown in the figure between next. The path is a circle. This is the fourth point of this equation. Okay. And next, number of turning point. 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 When the shape of the orbit is a hyperbola or parabola, there is only one turning point. Shape is hyperbola. Shape is hyperbola or parabola. Then only one turning point. 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 When the shape of the orbit is ellipse or circular. When the shape of the orbit, 1 minute. When the shape of the orbit, when the shape of the orbit, when the shape of the orbit, the shape of the orbit is elliptic or circular. There are two turning points. There are two turning points. And we will see the figure. See the figure. Figure is as like this, and this figure is as like this, and this is moving from in the direction epsilon is the less than 1. Epsilon is the less than 1. Ellipse. Which figure? Ellipse. The figure is elliptic. If the value of epsilon is less than 1. And this is the circle. Circle R. And the epsilon is 0. If the epsilon is 0, then the figure is circle. And if the epsilon equal to 1, the circle is the figure is parabola. Figure is parabola. And if the value of epsilon is greater than 1, the figure is hyperbola. The figure is hyperbola. Figure is hyperbola. Figure is hyperbola. And second point is central repulsive inverse square force. Second is central repulsive inverse square force. This is for a repulsive force. For a repulsive force. Equal to 1/2 m derivative of r square plus j square upon m r square plus c upon r. All the quantities on the right hand side are positive. Therefore, total energy is greater than 0, and the trajectory of the body under the influence of a repulsive force is always hyperbola. The most familiar example is the path of a positively charged alpha particle moving under the influence of a positively charged nucleus. Conclusion. Hence we conclude that for an attractive force E equal to 1/2 derivative of r square plus j square upon m r square minus c by r. The first two quantities on the right hand side are positive, and the last quantity is negative. The first two quantities on the right hand side are positive, and the last quantity is negative. And so E is the greater than or less than 0 according as 1/2 m derivative of r square plus j square upon 2 m r square is greater than or equal to or less than c by r, and hence according to trajectory will be a hyperbola. Parabola or an ellipse. For E equal to minus mc square upon 2j square, the trajectory is a circle. The trajectory is a circle. For repulsive force, the trajectory is always hyperbola. The trajectory is always hyperbola. Is always a hyperbola. Okay, this is equation number 1. This is the equation number 11. Okay, and this is proof that I'm next studying shape and size of elliptic orbit. Okay.